Beneath crashing waves and soaring peaks, China is quietly rewriting the rules of what's possible. From tunnels bored 78 meters below the sea to bridges floating higher than the Eiffel Tower.
It is super dramatic to be under this bridge. It's beautiful, and it is remarkable how high this bridge is and how long it extends.
This isn't just construction, it's science fiction turned real. One machine named Ding'ai is tunneling with millimeter precision under the ocean, while another bridge lets you sip coffee in the clouds. And that's just the start. Wait until you see what lies beneath the Yellow River. It's almost unreal. The Jintang Undersea Tunnel. The Jintang Undersea Tunnel is being built to become the longest and deepest tunnel specifically designed for high-speed trains. 16 kilometers total length, with 11 kilometers running continuously under the sea floor. At its deepest point, it sits 78 meters below sea level. At that depth, the water pressure is immense. Every square meter of tunnel surface faces roughly 7.8 atmospheres of pressure. A single structural failure could be catastrophic. It isn't just another tunnel, it is on track to become the longest and deepest tunnel in the world, built specifically for high-speed trains. Let's break down what that actually means. The entire tunnel stretches for over 16 kilometers. But the truly mind-bending part is that nearly 11 kilometers of that run continuously under the sea floor. At its lowest point, the tunnel sits a staggering 78 meters below sea level. That's like stacking a 26-story building upside down beneath the surface of the water. The pressure down there is immense, and it's an environment that pushes engineering to its absolute limit. So, why build it? The answer is connection. This tunnel is the crucial beating heart of a larger project, the Ningbo-Zhongshan Railway. Its mission is to link the major port city of Ningbo with the Zhongshan Archipelago, a group of hundreds of islands. For the people living on those islands, this is a complete game changer. Right now, a trip that involves ferries and bridges can take an hour and a half. When this tunnel opens, that same journey will be slashed to a mere 30 minutes by high-speed rail. It will transform a slow, disconnected commute into a quick, easy trip, effectively turning separate islands into a single, integrated metropolitan area. But building a tube for trains under that much water and rock is one of the most difficult challenges in modern engineering. The seabed here isn't a nice, uniform layer of soft sand. Engineers have to navigate a geological nightmare, a complex mix of rock and soil, crisscrossed with faults and fractures. The single biggest, most terrifying threat is water. A single leak under that incredible pressure could be catastrophic. Every single joint, every segment of the tunnel must be perfectly sealed. It is a constant, high-stakes battle against the ocean itself, a battle where there is absolutely no room for error. To win this battle, engineers have deployed two behemoths, two of the most advanced tunnel boring machines ever created. These are not simple drills. They are mobile factories, each the length of a large skyscraper laid on its side. Named Ding'ai and Yongzhou, these colossal machines are currently chewing their way through the underworld. They don't just bore through rock, they simultaneously install the concrete segments that form the tunnel walls, creating a sealed tube behind them as they advance. This is a feat of pinpoint precision. These machines, starting from opposite ends, are navigating the deep, guided by lasers and satellites, with the goal of meeting in the middle with an accuracy measured in millimeters. The construction of this titan is a marathon, not a sprint. The monumental work began in May of 2024. Progress is steady and hard-won. By October of the same year, the first of the giant boring machines, the Ding'ai, had left the relative safety of the land and began its epic journey beneath the sea. The current goal is for the two machines to complete their boring and break through to each other by the end of 2026. But even after that milestone, years of intricate work remain, laying tracks, installing electrical systems, and implementing sophisticated safety measures. The entire project is on track for its grand opening to traffic in 2028. The impact of this final connection will be profound. For the global economy, it links Zhongshan Port, one of the world's busiest, directly to the high-speed rail network, supercharging the movement of goods in the Yangtze River Delta. For everyday people, it redraws the map of their lives. What was once a barrier becomes a bridge. The Jintang Undersea Tunnel is more than just a transportation link. It is a statement of human ambition, a testament to what can be achieved when we decide to go through the obstacle rather than just go around it. The Yellow River Tunnel. The Yellow River Undersea Highway Tunnel took a different approach. Instead of carrying trains, it creates a massive highway passage with a bore measuring 17.5 meters in diameter, allowing a double-decker design with 6 lanes total. Its mission was to create a massive highway passage, and it earned its title as the world's largest diameter underwater shield tunnel. The sheer scale is almost incomprehensible. The bore of this tunnel stretches a colossal 17.5 meters in diameter. This incredible girth allowed engineers to implement an innovative single-tube, double-decker design, carrying 3 lanes of traffic on an upper level and 3 more on a lower level. This creates a 6-lane superhighway moving through a single, massive hole in the ground. But the truly fascinating part of this project is not just its size, it is the staggering pace famously known as China speed. The proof is in an almost unbelievable timeline. Construction on the tunnel began on September 1st, 2024. From that start date, crews achieved the impossible. They completed the entire 2-mile-long underwater shield section in a mere 110 days. The 2-mile-long underwater section was completed in 110 days. This represents an average boring rate of roughly 16 meters per day, exceptionally fast for underwater tunnel construction, where 10 to 12 meters per day is typically considered good progress. This unbelievable velocity was powered by a custom-engineered Titan named the Shenzhen-Zhongshan. This was not an ordinary machine. It was a technological marvel built specifically to conquer the soft, unstable soil of the Yellow River's bed. The Shenzhen-Zhongshan was a mechanical earth eater of immense power, designed to operate under extreme pressure while simultaneously installing the concrete segments that formed the tunnel wall behind it. It was the key that unlocked this record-breaking speed. While the underwater shielding was completed in that blistering 100-day period, the broader project continues. The tunnel is expected to achieve its full breakthrough by the end of 2025, with the entire route slated to open to traffic around September 2026. The completion of this titanic tunnel will do more than just set a new world record. It will provide a vital, all-weather link for the city of Jinan, turning the formidable Yellow River from a traffic barrier into a quick underground commute. It stands as a powerful example of how modern engineering is solving urban problems not by going over or around obstacles, but by plowing straight through them with a combination of brute force, brilliant innovation, and pure, unadulterated speed. The Shenzhen-Zhongshan Link. The Shenzhen-Zhongshan Link is a 24-kilometer integrated highway system that combines bridges, artificial islands, and a 5-kilometer underwater tunnel. The challenge: crossing 3 major shipping channels used by over 4,500 large vessels daily without disrupting marine traffic. Building a conventional bridge that would disrupt this vital economic traffic was simply not an option. The solution, therefore, had to be as ingenious as it was ambitious. This brings us to the heart of the project, a staggering 5-kilometer-long underwater tunnel. But this is not a tunnel bored by a massive machine. Instead, it was built using a technique called the immersed tube method. What makes this tunnel revolutionary is its construction. The world's first long-span immersed tube tunnel using a steel-concrete-steel composite structure. This design creates exceptional strength and durability for the extreme pressures of deep-sea conditions. Imagine building 32 gigantic, watertight concrete boxes on land, each one as long as a city block and as wide as an 8-lane highway. These colossal elements were then carefully sealed, floated out into the open sea like gigantic submarines, and precisely sunk into a pre-dug trench on the seabed. Once settled, the water was pumped out, and the sections were connected to form a continuous, watertight roadway deep beneath the waves. What makes this tunnel truly revolutionary, however, is its construction. It is the world's first long-span, wide immersed tube tunnel made from a steel-concrete-steel composite structure. Think of it like the strongest sandwich imaginable. This innovative design, where concrete is sandwiched between 2 layers of steel, creates a structure that is incredibly strong, durable, and resistant to the immense pressures of the deep sea. It is a pioneering solution developed specifically for the extreme challenges of this project, designed to last for a full century. Of course, such a monumental tunnel cannot just start and end in the water. This is where the 2 artificial islands come into play. Engineers constructed a massive 370,000 square meter island on the eastern side and a 130,000 square meter island on the western side. These are not just piles of sand. They are sophisticated engineering platforms that serve as the graceful transitions between the soaring bridges and the deep-sea tunnel. They are the vital portals where the road disappears beneath the waves and emerges again on the other side. Above the water, the link is just as impressive. It features a stunning suspension bridge with a main span of 1,666 meters, gracefully arching over the main shipping channel to allow the largest ships to pass unimpeded. The entire link is a massive 8-lane highway, engineered for speeds of 100 kilometers per hour. It was designed to be a pillar of regional development for decades to come. By slashing travel time across the Pearl River estuary from 2 hours to just 30 minutes, it effectively turns separate cities into one interconnected economic mega-region. The Dalian Bay Tunnel. The Dalian Bay Undersea Tunnel became the first cross-sea immersed tube tunnel built in cold northern China, where winter temperatures plunged to -22 degrees Celsius. This extreme cold threatened the concrete curing process, requiring entirely new construction methods. The result, a journey that once took an hour around the bay, now takes 5 minutes through it, reshaping the city's entire traffic flow by creating a new artery where once there was a blockage. So, how did engineers achieve this? They used a brilliant method known as the immersed tube technique. Instead of boring through the seabed with a massive machine, they built the tunnel in sections on land. Imagine crafting 18 gigantic hollow concrete boxes, each one the length of a large skyscraper laid on its side. In total, these sections stretched for over 3 kilometers under the sea. There were 13 straight elements, each a remarkable 180 meters long, and 5 curved ones, each 148 meters long, to gently guide the road. Once these colossal elements were perfectly constructed, they were carefully sealed, floated out into the bay like giant submarines, and then deliberately sunk into a pre-dug trench on the seafloor. Once settled, the water was pumped out, and the sections were connected to form a continuous, watertight roadway. This method was key to the project's success, allowing for high-quality construction in a controlled environment. But building the first cross-sea immersed tube tunnel in cold northern China came with a unique set of brutal challenges. The project spanned 4 long winter seasons, and the temperatures in Dalian Bay didn't just get chilly. They plummeted to a bone-shattering -21 degrees Celsius. Concrete must cure properly to achieve full strength. At -21 degrees Celsius, water in freshly poured concrete can freeze before the chemical curing process completes, creating weaknesses and cracks. The team had to develop special techniques to protect the massive tunnel sections during 4 winter construction seasons. The team couldn't use standard techniques. They had to invent new ones. Their most powerful weapon in this fight was the creation of what they hailed as the most advanced and highest capacity dry dock for an immersed tube prefabrication yard in all of Asia. This state-of-the-art facility was essentially a giant, shielded outdoor factory that allowed them to produce these massive tunnel sections with incredible precision and quality, all while protected from the worst of the freezing weather outside. The innovation didn't stop at the dry dock. To combat the cold, the team developed first-of-its-kind methods and technologies, specifically for these conditions. They had to adapt their concrete mixtures and construction schedules to ensure the materials cured properly without being damaged by frost. Every step, from mixing the concrete to sinking the elements, required new protocols. This wasn't just construction. It was a series of engineering experiments happening in real time, all to ensure the final tunnel would be safe and last for generations. The total project, a massive investment of approximately $1 billion, commenced in May 19 and wrapped up in April 2023, opening to traffic the following month. This timeline is a testament to the efficiency gained through these innovations, even in the face of such a hostile environment. The Dalian Bay Undersea Tunnel stands as more than just a convenient road. It is a landmark achievement for an entire region. As the first project of its kind in North China, it broke new ground, literally and figuratively. It proved that the advanced immersed tube tunneling technology, honed on projects in warmer southern waters, could be successfully deployed in the frigid north. It showcases a stunning ability to adapt to and overcome extreme environmental challenges. This tunnel is a powerful symbol of how modern engineering is solving urban problems, not by avoiding difficult conditions, but by developing the smart, resilient technology to master them. But China's conquest of impossible geography isn't limited to what's beneath the waves. To understand their full ambition, you have to look to the sky, at bridges that soar over some of the planet's most terrifying terrain. The Longjiang Bridge. The Longjiang Bridge stretches 2,000 meters across the Longjiang River Valley in Yunnan Province, with its deck suspended nearly 300 meters above the ground. Building here meant confronting 3 simultaneous challenges: seismic activity, high winds, and steep, unstable slopes in a remote mountain location. For drivers, it is a trip from one mountain peak to another, offering views that are as dizzying as they are beautiful. But this spectacular sight exists because of an even more spectacular engineering struggle. Building a modern suspension bridge is always a complex task. Building one in this specific location was a battle against nature itself. The site is incredibly remote, nestled in a deep valley surrounded by steep, unstable slopes. The area is also seismically active, meaning the ground can suddenly shake without warning. Engineers had to design a bridge that could not only hold its own immense weight, but also withstand the powerful forces of an earthquake. On top of that, the high winds that whipped through the valley posed a constant threat, trying to push and twist the lightweight bridge deck. This was a three-front war, against gravity, against earthquakes, and against the wind. The solutions were as innovative as the challenges were severe. The project began with the two massive towers that anchor the entire structure. These are not simple pillars. They are sophisticated feats of engineering, designed with flexible foundations and special materials that allow them to sway and absorb the energy of a seismic event rather than crack under the pressure. But the true marvel was the spinning of the main cables. These two giant bundles of steel wire are the backbone of the bridge, holding up the entire road deck. The two main cables were installed using aerial spinning. A helicopter carried a pilot rope across the gorge, which was then used to pull successively stronger ropes until individual steel wires could be pulled across and bundled together, a painstaking process repeated thousands of times high above the valley. The significance of this Herculean effort goes far beyond a simple river crossing. The Longjiang Bridge forms a critical link in the G56 Hangrui Expressway, a major artery in China's national highway network. By bypassing the slow, dangerous, and winding mountain roads that drivers once had to use, it slashes travel times and boosts regional trade. More broadly, it serves as a key piece of domestic infrastructure that supports China's ambitious Belt and Road Initiative. This bridge is more than just a piece of local concrete and steel. It is a vital connector in a global network of trade, a symbol of how overcoming geographical isolation is key to building economic connections. It stands as a testament to human ambition, a thread of modern engineering woven into the ancient fabric of the Silk Road. The Guiyang-Pingtang Bridge. The Guiyang-Pingtang Bridge features a rare three-tower design, with its central pylon reaching 322 meters into the sky, taller than the Eiffel Tower. This unusual configuration was necessary to span the deep Caodu River Valley, and it creates a striking visual effect nicknamed the cosmic eye when viewed from certain angles. This three-tower design is rare and visually stunning, creating a rhythmic, repeating structure that stretches gracefully across the deep valley. But the central pylon is what truly commands attention. It soars to an incredible height, making this bridge one of the tallest in the entire world. To be specific, the main tower reaches a dizzying 332 meters into the sky. That is taller than the Eiffel Tower in Paris. This incredible height was not just for show. It was a necessary solution to span the vast and deep Caodu River Valley below, a challenge that required thinking in monumental terms. This brings us to the feature that has earned the bridge its poetic nickname, the cosmic eye. When you look at the bridge from a distance, the combination of the three towering pylons and the gentle sweeping arc of the bridge deck creates a breathtaking optical illusion. The vast open space between the two main spans and the curve of the mountains in the background come together to form the shape of a giant, serene eye looking up at the sky. It is as if a celestial being has left its mark on the Guizhou landscape. This transformation of pure function into a form of natural art is what elevates the Pingtang Bridge from a mere construction project to a true architectural icon, a destination in its own right. Of course, such beauty is born from immense engineering challenges. The bridge sits in Guizhou's karst landscape, terrain formed from soluble limestone rock that creates underground caves and sinkholes. This unstable ground makes foundation work extremely difficult, as engineers must account for hidden voids and unpredictable subsurface conditions. Furthermore, the great height of the bridge makes it vulnerable to strong winds. Engineers had to design the entire structure, especially the long, flexible bridge deck, to resist these powerful gusts without shaking or swaying excessively, ensuring a smooth and safe ride for everyone crossing it. The primary function of this monumental effort was to bring the remote and mountainous Guizhou region closer to the rest of the country. The bridge is a crucial link in the expressway connecting Guiyang, the provincial capital, to Pingtang. Before its existence, travel through this area was slow and arduous, a series of winding roads that snaked up and down the steep mountainsides. The Pingtang Bridge changes everything. It flies straight across the valley, slashing travel times and fueling economic development by connecting people, goods, and opportunities. It stands as a powerful symbol of how modern engineering can overcome the most daunting natural barriers, not just with brute strength, but with elegance and vision, creating a structure that is as functionally vital as it is beautiful to behold. The Changtai-Yangtze River Bridge. The Changtai-Yangtze River Bridge combines three transportation systems in one structure: a high-speed railway rated for 200 kilometers per hour, a local road, and an expressway. This three-in-one design transforms what was once an 80-minute journey between Changzhou and Taizhou into a 20-minute trip, effectively turning two separate cities into neighboring districts. For decades, the mighty Yangtze River was a formidable barrier, separating communities and slowing down travel. This bridge changes everything, reshaping daily life and local economies through the power of direct connection. The solution for fitting three different transportation systems onto one bridge is an ingenious and complex asymmetrical design. The bridge features its high-speed railway line on one side of the lower deck, with the local road for cars and trucks running right beside it. The upper deck is dedicated entirely to a high-speed expressway. This asymmetrical arrangement, with the railway on one side rather than centered, required new engineering solutions to balance the different loads and vibrations from trains versus vehicle traffic operating simultaneously on the same structure. This side-by-side traffic layout is a world first for a bridge of this scale, a clever innovation that required completely rethinking how different flows of traffic can coexist safely and efficiently. This innovative approach earned the Changtai Bridge multiple world records, underscoring its unprecedented scale and strength. It holds the titles of the world's longest-span cable-stayed bridge for a combined road-rail system, the longest-span combined road-rail steel truss arch bridge, and the bridge with the longest continuous length of steel truss girders. These records highlight the monumental achievement of a structure built to handle immense and varied loads across its massive 1,208-meter main span. Supporting this three-in-one structure are impressive diamond-shaped towers, a blend of strong steel and resilient concrete. Their unique design provides superior stability against the powerful winds of the river valley, while allowing the flexibility needed for temperature changes. It took roughly 6 years of meticulous work to bring this vision to life. The completion of the Changtai-Yangtze River Bridge marks a new chapter in infrastructure, proving that the future of building is not just about making structures bigger, but about making them smarter, more efficient, and brilliantly multi-purpose. The Huajiang Grand Canyon Bridge. On September 28, 2025, the Huajiang Grand Canyon Bridge officially opened, instantly claiming the title of world's tallest bridge. Its deck sits 625 meters above the Beipan River, higher than stacking the Eiffel Tower on top of the Washington Monument. This nearly 2-kilometer steel truss suspension bridge represents the culmination of extreme high-altitude engineering in mountainous terrain. This isn't just a bridge, it's a sky road, a ribbon of steel and concrete that seems to float in the clouds above the staggering beauty of the Huajiang Grand Canyon in Guizhou Province. But this project is more than just a single stunning statistic. It is also the longest steel truss suspension bridge ever built in a mountainous region, stretching for nearly 2 kilometers in total length. Building a structure of this delicate balance and immense weight in such rugged, unpredictable terrain was a monumental challenge. Engineers had to contend with powerful winds, steep cliffs, and the immense forces at play to ensure the bridge would be not only record-breaking, but also perfectly safe and stable for a century of use. It stands as a testament to human ambition, a delicate dance of physics and raw engineering power performed on a grand scale. For the people living in this region, the bridge is far more than a record holder. It is a life-changing piece of infrastructure that transforms a once hours-long, dangerous mountain trek into a simple 2-minute drive. This connection breathes new life into local economies, allowing people to get to work, get to market, and visit family with an ease that was once impossible. The bridge incorporates tourist features, including glass observation decks and sightseeing elevators, transforming what was a major geographical barrier into both a vital commute and a breathtaking destination attraction. Thanks for watching. See you in the next one.